From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker. Today, I'm running solo. Welcome to the show. This episode of Fragmented is brought to you by BuddyBuild. BuddyBuild is a mobile-optimized continuous integration and delivery platform that takes minutes to set up. Thousands of mobile development teams love BuddyBuild because it's the fastest way to build, test, distribute, and gather feedback on their apps. With every Git push, BuddyBuild will kick off a new build, run your UI tests on real devices, and automatically deploy your build to users via Slack or email. With a simple screenshot, testers can send their feedback directly to you, along with important diagnostic details. Now, if your app ever crashes, BuddyBuild will record the frequency, affected users, and trace back to the exact lines of source code that caused the crash in the first place. BuddyBuild gives development teams like yours perfect insight into bugs and empowers you to iterate on your app faster than ever, knowing that you're building an app that your users will love. Join thousands of developers who've already added BuddyBuild to their development process. Try it free today at buddybuild.com. Today we're going to be talking about item number 13 from the Effective Java book from Joshua Block. For those of you that are just joining us, Kaushik and I are covering all of the items inside of the Effective Java book from Joshua Block in relation to how it applies to us as Android developers. We've already gone through the first 12, and today we'll be talking about number 13, minimize the accessibility of classes and members. I think Joshua puts this very well right out of the gate, and so I'm going to read this verbatim. And the paragraph is, the single most important factor that distinguishes a well-designed module from a poorly designed one is the degree to which the module hides its internal data and other implementation details from other modules. A well-designed module hides all of its implementation details, cleanly separating its API from its implementation. Modules then communicate only through their APIs and are oblivious to each other's inner workings. This concept, known as information hiding or encapsulation, is one of the fundamental tenets of software design. To be honest, I sat here for about 10 minutes trying to think of a better way to say this so I didn't have to quote it exactly, but it was too hard. Joshua literally hit this nail right on the head. The way he said this was so succinct and so perfectly that I couldn't replicate a better way to do it. So why is it important that we're hiding the implementation details and only exposing parts of our API? Well, it's important for many reasons, but most of which is the fact that it decouples your modules from how it's working and from how people are consuming it. Furthermore, it allows us to speed up the system development because these different modules underneath the hood can be developed in parallel. So what that means is if we have a library that we're building or a module, let's say that it has a public API. Now, all the internals of how that work could be split apart to multiple different developers, and that work could be done internally, and then the actual API component could be delivered to some other third party, some other company, whoever may be using it, so they can code against that, basically like an interface. That's the API that they're going to be working with. And the great thing about this is if we're hiding all of the implementation details, we can actually build those modules internally without worrying about breaking anybody else. Because as long as we're adhering to this public API that we've put out there, and we're not exposing the internals of how we're doing all of this work, then we don't need to worry about, hey, are we breaking anybody else? Because we can actually design it kind of in behind this wall. We can also test it, and we can also make sure that it works, and we can move much more efficiently. And one of the great things about it too is it allows us to essentially ship faster. So if we're able to do all of these things without impacting the consumers of our API, we can then deliver the product quicker. Furthermore, now while this does not allow immediate performance benefits, what it does is it does enable effective performance tuning. So what I mean by that is, let's assume that you've built your library, right? You have your public API of 5 or 10 methods or classes or whatever that people are using. Underneath it, you have 50 other files, and you realize at one point, like, wow, this one part of our library is super slow. How do we fix that? Well, we know it's in this component down here, and since it's because it's part of the internals of our library and we have not exposed those internals, well, we can now hop in there and change the way that works. Maybe we're using the improper data structure. Maybe we're doing something simple. Maybe we have a memory leak. We can actually go in and change the internals of that underlying internal part of our library and then ship maybe an update to that library. The interface may not change to it, so the public API may not change, but the internals below have now changed. We've now enabled us to have some type of effective performance tuning without affecting any of the consumers of the API. Okay, that makes sense, but how does Java enable us to facilitate any type of information hiding? Well, the access control mechanism that Java uses is something that we use every day, and it's probably, and to most of us, it's kind of second nature, so we really don't think about it too much at all. And that's using things like public and protected and private and all these different types of modifiers that are essential to information hiding. And understanding when to use them is key when you're developing software. Now, the rule of thumb here that Joshua clearly calls out is to make each class or member as inaccessible as possible. Now, in other words, use the lowest possible access level that you can while enabling your application or your library to do the work that it needs to do. Now, for top level classes and interface, you're basically almost always going to go with public. Now, some people do go with package private, but there are some weird idioms around that you can follow. But these are going to be the things that people are going to implement. These are the top level classes that are basically not nested. You're going to make those public. And so those are basically wide open. These are the things that folks can use. Now, here's the thing though. If you make something public, you are then obligated to support it forever to maintain compatibility. For those of you that listen to one of our other favorite podcasts, which is Android Developers Backstage, which is hosted by Chet Haas and Tor Norby, I've heard Chet on various occasions talk about building an API, and when you make a decision to implement a particular API, at that time, it's the best decision that you can make. And this is in regards to Android. They make a API public, and at that point in time, it's the right decision. 2 months down the road, they may have realized after they shipped that OS update for Android, they may realize that, oops, that was a bad decision. That API probably wasn't the best one, and they've made note of this in the podcast. But hindsight being 2020, we still can't go back and change it. And the perfect example of this is, let's assume that, and this has happened, Android has shipped an API, it's been released, and now all of a sudden, all kinds of apps start using it. Facebook, Instagram, Twitter, you name it, a whole bunch of applications start using this public API. The Android team determines, wow, that was not the best decision. We should have not had that one public, or we let it slip by through a code review on accident. Any number of things can happen. Now, they have to support that because let's use the example of, all right, well, they decide to yank it in the next version of Android. What would happen? They decide, hey, that API is bad. We're going to go ahead and pull it. And they pull a method from this public API. Now, let's assume a major application like Instagram is using that API. Folks decide that, hey, I'm going to update my phone up to the new version of Android. They update it, they open the Instagram app, all of a sudden the Instagram app just crashes. Now, I'm not saying anything negative about Instagram, I'm just using them as an example. This can happen to any application out there. I'm using Instagram because it's a very popular application and it would affect millions of people. So if the Android team was to remove an API that they've already released as a public API, they would not be maintaining backwards compatibility. And what that means is, so as soon as a new version of Android comes out, someone updates it, the app's going to start, it's going to look for that method or whatever it's going to be calling. It's not there. The app is then going to crash. So what the Android team has done over time has now marked these classes or methods or anything of that nature as deprecated and provide alternatives. Please start using this one. You'll probably have seen many deprecation notices all throughout your application. Android Lint does a good job at catching a lot of these in the IDE so you can see them. And you'll see a little strike through in the IDE saying like, whoa, that doesn't look right. That usually means you want to go take a look at the implementation. So hit Command B if you're on a Mac, and then look at the definition of that class. And it will actually have some notes in the Java doc saying this class is now deprecated or this method is deprecated. Go use this one, X, Y, or Z. And then you can see which one you want to use. Now, to kind of bring this full circle, the reason why this is important is because as an API developer, you have to make the best decisions as possible and realize that when you release something with that public API, you're stuck with that public API and you can't just pull it. Even if you hate it and you don't like it and it makes it painful, you have to keep it and work around it. Of course, there are always going to be times when people can remove them, which can cause pain and so forth. Now, is that something that you would want to do? That's kind of up to each team to determine if that's something they would like to do and can do. Maybe you're developing an internal library to share at your company that's used by 10 other apps, and you can make that judgment call to say, hey, we're going to yank this API. It was a bad decision. Let all the other developers know so we can update it within the company. However, if you're releasing a public SDK, maybe we're using the Facebook SDK and they remove a method, that can become very problematic. If an update is shipped, then all of a sudden your application breaks and you have to fix it. And this has happened to all of us before. We've consumed a third-party API and things change when versions change and all of a sudden things break. This is also why it's very important in Android to specify your exact version numbers in your build.gradle file. If in your build.gradle file you're depending on a dependency and you have a 9, say the version of the library that you're using is 9.0. Whatever. And in your build.gradle file, you said 9.0.plus or even 9 plus. What that's basically telling Gradle is like, hey, you know what? Like, just as long as it's like version 9 or like 9.0, like it's cool. Don't worry about it. Just go ahead and pull the new one down. Many developers have had those weird instances where they build it this morning, they do a bunch of development, they rebuild, and it breaks. Well, why is that? It's because perhaps some other developer has released a new version of that library, upgraded to 9.0.2. It has a breaking change in it. It's removed an API call or changed it. And all of a sudden, your app that worked 10 minutes ago doesn't work anymore. You didn't change anything. Why is this breaking on this library? I didn't change anything. Well, it's because you didn't specify your exact SDK, your exact version number in your build.gradle file. So this is a good reason of why you want to use a particular version number in the build.gradle file. And we'll go into this in detail here on Fragmented at a later time, but this is something that can affect you as an Android developer if a public API changes. So let's step back here into this effective Java item and talk about how we can actually lock down the access of particular parts of our application or our module. Now, assume we're building this module and we have a bunch of internals. You've probably looked at the source of many different open source projects and noticed that they have a package that's, com.example.foo.internal. It's a very common pattern where folks will put everything that they want internal that is internal to the library inside of this internal package. And a lot of times everything else outside of the internal package will be public. Now, this isn't written in stone. It's just a common practice that a lot of folks will do is just put the internal things in an internal package. Now, when they put those things in those packages, what you'll notice is they have different access modifiers. Neither does Java access modifiers. And let's talk about those for a second. We have 4. The first one we have is private. And private is basically saying the member is accessible from only the top level class where it's declared. So if we have a class like a customer class and it has a integer age field and we said private int age, that age field is only accessible within that instance of that class. Nobody else can access it. If someone's trying to say customer.age, they cannot get access to it. It's not allowed. The second one we have is package private. And this one says that the member is accessible from any class in the package where it is declared. Now, this is technically known as the default access. This is the access level you get if you don't provide any type of access modifier on a member. So let's say that we say create a class and it's called class customer. That class is now package private. So anybody that's in the same package can access that class. Also, let's just say we have a field. Again, let's use the integer field. That's the age. Instead of saying private int age, we just say int age. Now, basically any class or whatever that's inside of that same package can now access that age because it's now package private. It's only within that package can folks access all of those members. Number 3, we have protected. Protected is the member is accessible from subclasses of the class where it's declared. So again, let's just say that we have a customer class and then we have the field age and we put protected int age. And then at this point we just say, hey, you know what? We need to change our application to support platinum customers and gold customers. And so you inherit from the superclass, which is now customer. And so you have a subclass of customer, and that's called platinum customer. Well, because the customer's age is marked as protected, the platinum customer can have access to the age. The gold customer, which is a subclass of customer, can have access to the age. But anything else, perhaps like an employee object, which is a completely different class, cannot have access to the age because it's not a subclass of that class called customer. And finally, we have the very popular public, and this is a member that's accessible from anywhere. So this is one we're very familiar with. You mark it public, anybody can access it. So if we have that customer class again, we mark that age as public int age. anybody can get access to that age. And we can kind of have a whole bunch of problems there, which we'll talk about in a second, but it is the most open there. And as soon as you mark something public, basically you need to support it from that point forward. Now let's talk about public classes for a second. If we have a public class, we have a huge increase in accessibility when the access level goes from package private. So basically saying, hey, everything in here is package private. You have to be part of this package to access it, to protected. Now, a protected member is part of the class's exported API and must be also supported forever. Because remember, anybody, let's say we have we're having a library that exposes a customer object that before was package private. So nobody could talk to that int unless you were in that same package. And your application, since you're consuming that third-party API library, is not part of the same package. You don't have access to that integer. So now let's say for some reason we change that from the default access level, which is package private, to protected. As soon as we do that, we now open up that as part of the public API, because now I can subclass the customer object and create my own type of customer. And I have access now to that age because it's now a protected access modifier level. So now I can actually subclass it. Now I have access to it. It's part of the public API. So be very aware of that. As soon as you change something from that is part of the public API that maybe was packaged private before, and you change it to protected, and now it does become part of your public API. So it's something you need to think about quite a bit. Now there's one rule that we need to make sure that we're aware of here when you're trying to reduce accessibility of methods. If you have a method that overrides a superclass method, like maybe it's, calculate, some type of value for your object. If you override that in a subclass, you cannot change that visibility of that. You can't change it saying, hey, this was protected before, now I want it to be private. Because if you do, the compiler is going to complain and just basically not let you do it. So you have to keep that same accessibility. Now, I've been on both sides of the field here as an API developer as well as an API consumer. And throughout the years, there's been many times in which I wished a particular class or something of that nature was much more accessible. Maybe I wish it was public so I could have access to it. And the main reason for that is either I needed to provide some type of different implementation, which the class didn't allow, or I needed to facilitate for testing. If you need to facilitate something for testing, you may be tempted to make everything more protected or more public so you have an access to it. Now, realize that that's not necessary. If you're building the API yourself, you can provide an interface for folks to use, and they can then go ahead and mock things out. And with new versions of the mocking tools, you can even mock final classes, which is amazing. But if you're worried about testing your own library that you're going to be publishing to external folks, you don't have to make all those public because your tests are going to be internal to your application anyway. So if you have things that are packaged private, you can leave them that way because your tests can then access those because you'll be part of the same package. There's not really a need to open up your API as much as you think you needed to for testing. Now, Joshua makes a couple of other statements inside of this item here, which are very important. And one of those is instant fields should never be public. Now, basically what that means is we shouldn't mark any of those instance fields. So if it's that customer's age, we may not want to mark that public. And he's saying never do this, because we give up the inability to take any action when the field is modified. And so classes with public mutable fields are not thread safe. So that's kind of a big aha moment for a lot of folks. And especially me, when I first read this, I was like, oh, wasn't super aware of that and never really thought about that too much in detail. This also applies to static fields with one exception. You can expose constants via public static final fields, assuming that the constants are basically primitive values or references to immutable objects themselves. So you just want to be aware that you want to stick to that rule, except for that one little kind of variation there. Joshua also makes mention of something that's very kind of tricky when you think about it. And he says that non-zero length arrays are always mutable. So it's wrong for a class to have a public static final array field or an accessor that returns such a field. And so what that means is if you're returning like an array of, customer values, that can always be mutated outside of the class. And so you'll run into a bunch of problems and crazy bugs and security holes when you actually expose a public static final array field or an accessor that returns such a field itself. So you want to be careful around that as well. Now you may be wondering, well, I need to return an array of things. How do I do that? There's a couple of ways that you can fix the problem. You can make the public array private and add a public immutable list. And you can use things like collections.unmodifiable list, and then it will return an unmodifiable list using the collections utilities. And then alternatively, you can also make basically a copy of that private array and return that copy of the private array so it's not the same one. Now that could be confusing to folks thinking that it's, hey, I'm getting back an array. I think I can modify it and that should modify my existing array in memory, which can then add to some confusion in your application. So you may want to be aware of that too. And in the end, you need to choose between these alternatives if you're returning an array and think about what's the client likely going to do with that result. Which return type will be more convenient for them, and maybe even what's going to give more performance. Now that kind of wraps it up for item 13. It's all about accessibility and basically minimizing your API footprint. Because remember, if you mark something as public or it's available as part of the public API, you're going to have to support it because people are going to rely on it. So you kind of want to hide the internals away. And why is it easy to hide the internals away? We want to do that information hiding that we talked about before. It allows us to develop in parallel much quicker. We can iterate, build tests. It also enables effective performance tuning because if for some reason that library that we ship kind of doesn't really operate and function that well, we can hop in there, take a look at the internals and fix it, ship another version, and still not break the public API. Now, I hope that helps. I'll talk to you next time. Well, that's it for the show, folks. Fragmented is hosted by myself, Donn Felker, and Kaushik Gopal. Unfortunately, Kaushik's not with us today, but he'll be back soon. We miss you, buddy. We edit and produce all of the Fragmented episodes ourselves. The amazing Sarah from the Spec Network helps with production assistance and wraps our final mix. Our theme music and ad music is produced by Alan Taylor. You can find more episodes of the show on Pocket Casts, on Google Play Music, or any of the podcast players in town. We do have to say, though, we love Pocket Casts. Our website is fragmentedpodcast.com, and you can find the links to all the stuff we say on our website. Thanks for listening. We'll see you next week. Once again, we'd like to thank our sponsor for this episode, BuddyBuild. BuddyBuild is a mobile-optimized continuous integration and delivery platform that takes just a few minutes to set up. Join thousands of developers who've already added BuddyBuild to their development process. Try it free today at buddybuild.com.